Hello, classrooms. My name is Brent Peltola. I am the Executive Director of Partners in Research Canada, and I am your host for our PIR live event today featuring Tabetha Sheppard. Tabetha is a master's student at the University of Western Ontario, studying planetary sciences and geology. Her research focuses on a crater in southern France to understand what happens in hot water systems after an impact crater is formed. Tabetha also has many space-related interests outside of geology, including space policy and law, analog work, and cosmochemistry. So without any further ado, I will pass you over to Tabetha. Welcome to the PR Live event.
Hi, thanks for having me.
All right, so we can get your presentation shared.
I'll start sharing that right now. There we are, get it in presenter mode. There we are. So, of course, I'm here to present a little bit about my research, but I figured I'd start off with a little bit about myself so you know a little bit about what I know. So just a little bit about me to start. I did my undergraduate work at the University of Ottawa in French, and I worked as a tour guide for many years. So there's a picture of me down there working at Parliament, where I was a tour guide there for 3 years. And I graduated with a degree in geology there. And then I moved all the way along about 7-hour drive to London, Ontario to start here at Western University. So we have a picture here of the Cronin Observatory and the microscope lab where I spent a lot of my time with my little Mars and Comet friends. So I have them in the lab with me all the time, helping me out with my research, and they actually have their own Instagram as well. So they're pretty great to have around. And what do I do? So you hear the words geology and you probably wonder, oh, is it just rocks, or what do you do necessarily? And it does involve a lot of rocks, and it involves quite a lot of traveling as well. So I've been to places like the Bahamas, to a small island of San Salvador, Death Valley, to the salt flats there as well, and to map some of the mountains, and even back home to my hometown of Sudbury to study its impact structure, which is this photo up here. As well, we always carry around big rocks with us. So that's a little bit what I do. I study rocks, but also get to travel around a lot to study these rocks, which is why I like geology so much. But I didn't want to just stay in geology. There was something missing. And when I was a kid, I always loved space. I would look up to the stars and I would think, wouldn't it just be so cool to be an astronaut and to go up into space? So I've always been involved in the space world. So I would always keep up with the news and very interested in exploration of space. So I went to a bunch of conferences like this one here, where I was able to meet some of the Canadian astronauts. And this one here was the Canadian Space Summit in Ottawa, where I first met my supervisors, who I now do research for at our Western Institute for Earth and Space Exploration. This photo here was taken during the launch party for our institute. But funny enough, it all links back to my hometown of Sudbury. So if you look here, Chelmsford is actually where I grew up for most of my life, right in the middle of a giant impact structure, which I didn't even know was there until I moved away from the city. So I moved to U Ottawa to go to school, and I started studying geology there. And I found out that my hometown was hit by a meteorite almost 3.5 billion years ago. And I thought that was just the coolest thing to ever happen. And I had to know more. So I wanted to keep studying impact structures. And that kind of leads me to what I'm studying now. So to get into what I actually study and get into the science of it all, I study impact craters. And impact craters are what's left over on the terrestrial planet, like Earth, Mars, or even the moon, after a really, really quick meteorite slams into the Earth. And when meteorites hit into the Earth, it leaves this circular kind of hole in the ground. It actually hits so hard and so fast that all of that kinetic moving energy turns into heat. And it'll completely vaporize the top layer of rock and then melt a big layer below. So you'll end up with this liquid magma-y type rock, like what you would see oozing out of a volcano. And it also shatters and breaks up the rocks underneath. So it is extremely catastrophic event. And we now know that impact craters are what caused the extinction of the dinosaurs. There's a crater called Chicxulub in Mexico. And we're starting to learn a lot more about impact craters and discover new ones every day. But I study something very particular about impact craters, something that I like a lot because it links to two of my passions. So I study hydrothermal fluids. In case you don't know what hydrothermal means, we're going to break it down. So hydro simply just means water, and thermal, of course, means relating to heat. So pretty much hot water. And like what we were saying, when the impact structure forms, when that meteorite smacks into the ground, most of that quick kinetic energy gets transferred into heat. And that heat is able to warm up any water that is surrounding the crater. So whether it be having hit in the actual ocean itself or in a sea, there would be plenty of water to heat up around it. Or it could also just heat up the water that was inside of the minerals or just stored inside of the earth. So little bits of water or OH, even H2O, can be found just in a solid rock. And really, really hot temperatures and melting can make that water come out. So we have lots of opportunity for hot water to flow in one of these impact structures that we're looking at. And hydrothermal fluids are very important for life. So around hydrothermal vents, which a lot of people learn about, they're at the bottom of the ocean. And it's these little vents here where you see all this hot water coming out. And we know them as black smokers or hydrothermal vents. And a lot of people will learn about these environments because bacteria or pieces of protein and organic cells and compounds are actually born, a lot of them, in hot water or in extreme hot environments. And like these little critters that I've kind of added onto the screen here, a lot of living things will like gather around these hydrothermal vents because there's a lot of nutrients and minerals coming up through that hot water that can help them live and grow. So hydrothermal vents and fluids is a great place to study life and what we call extremophiles as well. So bacteria and other types of organisms that like to live in extreme heat environments. So hydrothermal life on Earth does exist. We have lots of these black smokers like we were talking about. But as impact craters cool, like what we were talking about, they have a great environment for microbacterial life to thrive. You have potential heat, you've got lots of breaks and fractures and regions in that crushed rock underneath where all that water can flow up and through. And within those cracks in the crater, there can be lots of hot water flowing and a perfect location for microbacteria to live since it's protected from UV rays up at the surface. Living in those little cracks might be a really, really great place to live. So we're actually starting to wonder if life originated on Earth in both the ocean and hydrothermal vents and on the surface through impact structures. I'm not quite a biologist, I'm a geologist, so I'm not too sure about that one. I'll let those experts take a look at it, but it would be really cool. But we do use these impact craters and the fact that they have hydrothermal fluids through them in space exploration, and that's a little bit more of what I do. So then if we're looking for life in space, and you're wondering where to look, the perfect location and answer to that might be in craters because they have the potential to have had water heated up, even though they didn't necessarily have a lake right in that location. So Gale Crater, it was actually the choice location for the Mars mission Curiosity rover. So Curiosity is here in this crater right now as we speak, doing science in the impact crater. And there's lots and lots of reasons why impact craters are the place that they send a bunch of Mars and moon rovers as well, not just because of hydrothermal fluids, even though that's more what I'm interested in, but why craters in general? The answer is because they have everything that we might want to study in one location. So when an impact hits, it also sends out and skyrockets out material and rocks to outside of the actual circle. So this is called ejecta. And that ejecta has a mix of all of the rocks that were originally inside of the crater. So if you take a sample of that, you're able to actually sample multiple rocks in just one little sample. So it's a great location to be able to choose rocks to bring back to research or to study. And also there's this central location, which we can call a peak ring or a central uplift. And those are just fancy words that we use, but only a couple of seconds after the meteorite hits, the center of it will actually bounce back up because it wants to be equal and wants to have this rebound. So the inside will actually bring up almost 20, 30, 40 meters of material up to the surface that was originally deep underground. So we also have access in craters to deeper material than we could ever drill to with a rover. So the center of craters are really helpful to look into what would be deeper into the planet. And then also we have those minerals that I call clays and sulfates, which are water minerals. So those are the minerals I was mentioning that can hold water inside of the mineral, and that's what can be heated up to make hydrothermal fluids. And these minerals here can actually tell us if there was any hydrothermal fluid at that particular crater. And these clays and sulfates were detected at Gale Crater here through the use of orbiters that can look down with special instruments to be able to detect those types of minerals, which means there's potentially hydrothermal activity, and then potentially could have been a good breeding ground for microbacteria. So scientists chose Gale Crater as the landing site for Curiosity because it has many signs that water was present over its history. Water is a key ingredient to life as we know it, which is a quote from NASA's pre-launch when they chose Gale Crater as the landing location. So you can see water and hydrothermal activity potential is actually a really big deal when you're trying to choose where to go look for life and landing spots on other planets. So that is a little bit what I study. I've got a cute little comic up here of Mars saying to Earth, you need to get a life, and the Earth saying, who, me? I already have something like 7 billion. So we're hopefully going to be able to find microbacteria and other forms of life on Mars someday, and maybe it can have some life as well, but that's a little bit more of what I study. Which links us into the junior astronauts activities. I'm assuming we're going to do this before questions.
Well, we could throw a couple of questions out now, and then we can get into that. Just a reminder to the classrooms, if you have questions, please open your Q&A window and submit them there, and I will relay them to Tabetha. So I don't see this question in the window, but we often get the question about the meteorites killing the dinosaurs. So what is the mechanism of them actually being able to kill the dinosaurs? How did that happen?
Yeah, so it's actually many layers for it to have affected the dinosaurs and create this mass extinction. So you can imagine a very large meteorite hitting the Earth will be devastating to at least the region where it hits. And in Mexico, actually, where it hit was partially underwater when it did hit. So one of the main devastating parts was a massive tsunami which hit after the meteorite. So a couple of minutes after the meteorite settled, then a huge, over, I think they said 100 meters or 100 feet tall tsunami swept over the region. And within the core, so they'll take these thin tubes of rock straight from the center of the crater, which we call a core sample, and it comes out to be a tube about this big of rock, meters and meters long. They actually found scorched carbon, so organic material within the core, which means everything within a close region around the meteorite was actually scorched and heated up So everything really close by would have been burnt. And then if you weren't affected generally by the couple of kilometer radius around the meteorite, there was also something special that it hit into, which are called evaporite deposits. So it landed in an area where there was a lot of sulfur, because there is a mineral called anhydrite, which is a calcium sulfate, so CaSO4. And all of that anhydrite, when they looked at the core, was gone. So all of the sulfur was released up into the atmosphere, which will cause significant cooling of the entire planet. So it basically blocks out the sun's rays. So it cooled down over a course of a decade by about 20 degrees centigrade. So a massive cooling event happened, which will cause an extinction of certain animals or microbacteria, even if they can't adapt to the new environment. And on top of all of the forest fires that will have started from the scorching of the region, there's also a blanket of smoke, which will then darken the region. So you're still not getting any sunlight peering through, which will cause a lack of vegetation. And with that lack of vegetation, there would have been nothing for the dinosaurs to survive off of. So it's a really multi-level problem.
Excellent. So a couple of questions from the Q&A window from John Ross Robertson School. Was bacteria found in the crater that you showed to us on Mars?
In Gale Crater, so they haven't particularly found bacteria itself, but they have found these calcium sulfates. So what I was telling you about anhydrite, there's actually a almost twin mineral to it, which is called gypsum. And it's actually what's used in your drywall, which is why we call it gyp rock a lot of the time. And it's calcium sulfate as well, but it has 0.H2O. So it has water inside of its structure, which means we know there was water present on Mars. So we've been finding a lot of water-rich minerals and water potential in the craters. But seeing as we're so remote and we're just looking through cameras and doing a lot of zapping of rocks with a laser to be able to identify them, they haven't necessarily found bacteria. This is one of the main reasons why they want to take samples and return them. So the 2020 mission, which we just got heard the rover is going to be called Perseverance, which I'm very happy about the name choice. So Perseverance is actually going to be attempting to take samples of rocks and place them in a location for us to be able to go back and get later on. And we're hoping in bringing home to Earth these samples, we would be able to really go in and look under a microscope to be able to find potential bacteria or signs that there was at one point bacteria. But without bringing them back, that would be extremely difficult to tell.
All right. So from Justin Reventar's class, Anmar is asking if it's true that there's a meteor heading for Earth.
So this is something we hear a lot of. There's a meteor headed to Earth, and it could potentially always be true. So we call a lot of these objects near Earth asteroids. And we have a lot of rocks floating around space near us, which we have to look at what we call their orbit. So where are they going? Are they following a specific planet's gravity? And are they being pulled in towards the Earth? So asteroids at any time of any day could be going by. It's just the question of if they get close enough to be sucked in by our gravity and pulled into the Earth. So that's a lot of astronomers who will look up into the sky and monitor different asteroids and how fast they're going and where they're going to be able to see if they will potentially fall down onto the Earth. But a lot of the times we would be able to tell ahead of time if they're headed towards us and if we should actually be worried. So at any given moment, we could always have an asteroid headed towards us. It'll probably miss us though, because we do have that magnetic field and a very strong atmosphere that if it's a little tiny piece, it'll just burn up in the atmosphere and we won't even notice, and we'll just see it as a shooting star. So technically, yes, there is always kind of an asteroid headed towards us, but super dangerous, no.
So the follow-up question from Maureen is, how big would a meteor have to be to destroy the Earth?
To destroy the whole Earth, that would have to be pretty big. We even got to, so our moon was created by us being hit by another massive planetary body, a kind of an asteroid, you might say. And it just took off a chunk and it got stuck in our orbit and created our moon. So to actually destroy the planet, I think we would have to get hit with something really big, but I don't know the math on that. But to cause, you know, an extinction of certain living beings, it could be 20, 30 kilometers like wide initially, but it'll break up into pieces in the atmosphere. So you've got to hope that it breaks into small enough pieces to not actually hit too drastically on the Earth. But I'd say, you know, a couple tens of meters or hundreds of meters could be devastating to the location it hits, just due to potential sulfur or blanketing of the atmosphere. So anything too big, we should be worried about. But normal asteroids would probably break up in the atmosphere a significant amount and not really worry us. So it would have to be pretty big, but I'm not sure the exact size.
All right. So we have a couple of the questions in the Q&A window, but we'll leave those for a minute and we'll get back to the presentation, but we will get back to your questions in short order.
Perfect. So I'm here to talk about some of the Junior Astronaut Campaign information that we have for you. So if you haven't heard of the Junior Astronauts Campaign, it's mostly geared towards students from grades 6 through 9. So if any of your classes are grades 6 through 9, this might be a great opportunity for you. Just in case there are any classes, I will run through these opportunities as well. So the junior astronauts, you see moon mission written on it and you see a young astronaut. And this is because they have a goal and an objective of getting Canadian youth excited about science by using space. So a lot of people will think space is super cool, but maybe not really care about the science or not understand why the science is cool. So if we're able to show how cool science is through space, I know that's why I got interested in sciences, was through space. So trying to get more people involved in the space and science industry, but also to inform youth about careers in the space industry and what it takes to become an astronaut. So more the fact that you don't have to be an astronaut to work in the space industry. I'm a grad student studying geology and rocks, and I get to work in the space industry. And I know some graphic designers who also work in the space industry. So there are definitely a lot of opportunities that are not STEM or engineering related. And also, finally, the most exciting one is to show you how you can play a mission in future missions to the moon. So this is a little bit what the website looks like. You've got streams and activities, attend the camp, and win an astronaut visit. So that's the three main parts of this campaign. So the streams and activities, what they're saying is there are 3 streams of activities. There's fitness and nutrition, science and technology, and teamwork and communication. And there's activities in each one of those streams that teachers and educators can go and access to be able to give to their students, to be able to have space-related activities or science-related activities to present for free in the classrooms and have access to. Whereas when an astronaut visit, the deadline has already passed, but any classrooms who had completed 1 or more activities from each stream could apply to win a potential astronaut visit to their school. So that deadline was at the end of February, but you still have a little while for this attend the camp. And what attend the camp is if as a student through grades 6 through 9, if you complete 1 activity from each of those 3 streams, you can use certificates to say that you've done them to go online here. You click register and then attend the camp, and you're able to enter a completely randomized draw to be able to win a 1-week free summer camp to the CSA, where you get to meet space scientists and engineers and train like an astronaut for a full week at their headquarters in Saint-Hubert, Quebec. So it's a really great opportunity, and they're hoping to inspire youth to go into the space sector through these activities and through this camp opportunity, and hopefully keep it going as well. I know this is the first year they're doing it, but it's a very, very interesting opportunity. And these were some of the important dates. So as you can see, the visit contest has already come to pass, but for the submission for the camp, you have until March 29th if as a class you want to do all 3 of the activities and be able to register to potentially go to this camp. And they'll announce the camp participants in April, and the camp will either be in July or August. So those are those 3 streams that I was talking about. So science and technology, fitness and nutrition, and teamwork and communication. It's very important for astronauts to have all 3 of these kind of streams of traits. So you can't necessarily just be good at science and technology. You also need to be fit and have good nutrition, just because being an astronaut right now, you do need to be fit and healthy, because you wouldn't want anything to go wrong up in space, or you need to be physically fit enough to complete the tasks. One day, of course, we hope space is accessible to absolutely everyone, but the job of being an astronaut and servicing the ISS currently does require quite a high level of fitness and nutrition. And then, of course, teamwork and communication is absolutely important in everything you do, including the fitness and the science and technology, because you are up in the International Space Station and you're both working with a team who's down at, say, Houston at Mission Control, or you're working with a team of people who are up there in the space station with you, who may not all be from your country. So there is a lot of international collaboration. You need to be able to work together as a team, and also to communicate with both your peers on the ground and up in space with you. So these are 3 really important things if you're looking to be an astronaut, and kind of the things you'll be training in if you do get to attend the camp. So the activity we're going to run through together today is called Survivor Moon. It's actually one of my favorite activities because we get to talk about the moon a little bit. So as I'm assuming some people might have heard about the new Lunar Gateway project that Canada has signed up to be a part of. This is kind of what it's going to look like, and it'll be similar to the International Space Station, but it orbits around the moon instead of orbiting the Earth. And it will only be inhabited by humans about 3 to 4 months out of the year. So it's going to be a lot more independent. And this is what the Gateway is kind of conceptualized to be. And you can see Canada and our CSA logo right here has signed on to take charge of the robotics. And like I was saying, since it's going to be a lot more remote and operated without humans there, this new robotics challenge for Canada is quite a big one. So we'll have to be able to use all of the robotics remotely from the Earth to this station. And it's even farther away from the Earth than the International Space Station. So quite a few engineers are going to be working on this for quite a long time. So maybe even some of you listening right now could be working on this next robotic masterpiece, let's say, we're putting together, which is kind of going to look like this, which was an artist's rendition of potentially what Canadarm3 could be. So Canada is very well known for our robotics. We built Canadarm1 and 2, which are these arms that attach to the International Space Station. And we were asked to make this 3rd one for the Lunar Gateway. And that's what MDA, a Maxar company, is currently working on. But really, we're hoping to, like we were saying, inspire the future generations to come and work on these missions. And it's not just building robotics that the Lunar Gateway will take in, but also science, investigation, and missions. So getting this kind of a gateway around the moon set up is going to help us go even further into exploration as well, or economy. We'll have an easier access to the moon. So we might even be able to make a settlement on the moon and have humans on the surface of the moon for longer periods of time and create habitats and actually stay there. And then for exploration and economy, having this around the moon will open up space mining opportunities on the surface of the moon and further, or even help us pit stop at the moon and then go further all the way to Mars in further exploration. So it's a great opportunity in exploration, and so glad Canada signed on to be a part of it. So this is why we want some junior astronauts. We're going to need to send astronauts to the Lunar Gateway and to the surface of the moon, which will likely be about youth your age who, when you become astronauts about that age, which will mostly be lunar missions. So really hoping to inspire you all to go to the moon. And Survivor Moon is a fun activity actually designed by NASA quite a while ago, where you have this scenario. So picture yourself, you're a team that are astronauts from the CSA, and you're headed to an outpost on the near side of the moon. But your lunar capsule goes off course during your descent to the surface, and you land over 50 kilometers away from where you're actually supposed to be. In your capsule, though, you do have 15 items which they packed for you that might help you survive on your journey to the actual outpost that you need to get to. So as a team, the task of this is to look at these 15 items, which I'll put onto the screen, and rank them by priority of which one is the most important to have and which one would be the least important for you to have. And then we'll ask you how you ranked these items, and you will have access later on as well to the answers. I'm not going to give you the answers because I feel like that would be too easy. But these are the items you have, and they have been ranked by actual astronauts at NASA, and that's what you'd be comparing your answers to at the end. But we'll go through a few of these items just to see, give you some ideas what they might be useful for or not so useful for. So a stellar map would be almost a map of the stars, and it might help you in guidance. So you'd have to think if that is important. Would it be important to know where you're going? Or would that be less important than some of these other things? So a case of dehydrated milk, you can think of that as a potential for food or maybe something to drink. But one thing to keep in mind too is how difficult are these things to carry? And how will you carry all of these things 50 kilometers away? And can any of these things help you get 50 kilometers away? So we got things down here like a heating unit, some self-inflating life rafts. Can you potentially use those to help transport other things? And how important would those be? Things like oxygen or food or water, you might want to think as higher up on the list for self-survival, that kind of thing. And also remember where you are. So you're on the moon. Try to think of what would be helpful on the moon and what would not necessarily be helpful on the moon, even if it's something that might help you here on Earth. So the moon and Earth are different in many ways. So try to think of that as well. And then when you take a look at the answers from the actual NASA astronauts, they do have a little bit of an explanation as to why they marked them at certain importance. But I think it's a really good activity to be able to think through what would actually be useful to you on the moon. Right away, I'll give you my number one that I'd put low is this box of matches. Because if you think about it, on the moon, you're at very low gravity, and the moon does not have an atmosphere, so it's lacking oxygen. So you actually would not be able to light that box of matches at all on the surface of the moon. So I would put it pretty low down on my list just to get you guys started. And that's the activity. And I'll open it up to more questions either about the activity. If some of you have done it before, maybe you can tell me how you rank them. But if not, I would suggest doing it. It's a really fun activity.
Excellent. Thank you for that, Tabitha. I'm just going to stop your presentation.
Sounds good.
We have a few more questions in the Q&A window, and just a reminder to schools, if you have a couple more questions, please go ahead. We are a couple of minutes over, but we'll get to these ones for sure. So one of the early questions that we got that we didn't get to was, when people land on Mars, how will they get water?
Yeah, that's actually one big question right now. Even for the moon, it's water. How do we get water? A lot of research right now is being used at being able to mine water on the locations where you land. So like we were saying, there might be hidden water in rocks or even just underneath the surface. like here on Earth, we have these big water storage under the earth, which we tap into to make things like wells or get water. So there might be on the moon ice that is trapped inside of rocks that we will be able to kind of take out. And on Mars, we're hoping that there might be a way for us to take water out of certain minerals or dig down into the ground and be able to find reserves of water that we'd be able to mine out of the planet itself. That is still completely in the works, where people are trying to figure out where the water will be and how to get it out. But that is a plan of being able to actually mine water where you are instead of having to carry it with you all the time.
Excellent. You mentioned in one of your slides the potential economic upside to being on the moon. Rayhan was asking if you can mine meteorites for minerals like you might mine on the moon.
Yeah, so kind of like asteroids and other bodies are something that is definitely being talked about as a mining resource. Mostly when we talk about space mining, a lot of people would think about going up into space, mining something, and then coming back down and selling it on Earth. But that is probably not the case, because the most expensive part of space resources is the transportation. So fuel is extremely, extremely expensive. So if you can mine something up in space, usually the best place to sell it is in space itself. So if you're able to mine something from the moon, like let's say water or iron or other elements, it would be great to be able to then use them in a rocket up at, let's say, the Lunar Gateway to refuel. So that is the type of mining they're thinking. So asteroids can definitely be mined, but they would likely be mined by someone or a group of people who are already out in space and selling to someone else who is up in space as well, doing exploration. So we won't necessarily mine things and then bring them back down here to Earth, but space mining definitely is something that is kicking up in the world of space industry.
All right. So our last question, and we will keep it to this because we are over time, is less geology and more geopolitical. What countries claim that the moon is theirs?
Yeah, so this is a little bit more into the space policy and law, which the moon actually cannot necessarily be claimed by a specific country. According to the main treaty of international space law from the countries who signed it, were that no country or specific government could own an entity in space. It does surmount the problem of some countries did not sign this international agreement, so that might be an issue later on. But so far, there's the laws in place that say no exploration country can necessarily own a specific right to, say, the moon or Mars or any kind of asteroid just yet, unless they change it. But so far, no one can actually claim it to be theirs. So I haven't really heard of people claiming it to be their own, or more, they just claim that, oh, we've been there, and since we're the only ones to have been there, it's kind of our location. But no one is owning the moon necessarily.
All right. Well, that sounds like a good note to end on. So thank you very much. Tabetha, thank you for your time today. It was wonderful to hear about your research and your work on space exploration.
Amazing. Thanks for having me.
So to our classrooms, thank you for joining us. Just a reminder that we have another Junior Astronauts live event on Thursday this week. Our guest will be Chimera Andres, also a master's student in planetary geophysics at Western University. Chimera studies the movement and stability of ice in glacial and periglacial environments in the Canadian high Arctic, and how it is shaping the landscape over time in comparison to Mars. So I hope classrooms can join us for that, and look forward to seeing you on a future live event. Thanks a lot. Take care.